So we know we can represent a graph in rectangular coordinates. So rectangular coordinates are of the form y equals f of x. We can also represent a graph in terms of a third variable. So my third variable is going to be time, or t. And then we can look at the vertical and horizontal changes with respect to that time. And we call these parametric equations. So I have a definition. If f and g are continuous, and they're functions of t on an interval I, then I have the equations x is f of t and y equals f of g of t. Our parametric equations are called parametric equations. And t is a parameter. The set of points x, y obtained as t varies over your interval is the graph of the parametric equation. Taken together, the graph and the equations are called a plane curve. And then we call that C. Okay, so now we're going to talk about the plane curve. So a curve C is represented by f of t and x and x is f of t and y is g of t on an interval I, is smoothed when the derivatives are continuous on I and not simultaneously 0. Except at the endpoints. And it's piecewise smooth when it's smooth on the subarintervals. So the other thing that we like to talk about when we talk about parametric equations is the orientation. If I talk about the orientation, you'll see if you graph, and you can graph on your calculator if you go to parametric mode with the two equations in, and you'll watch it graph, and it could either it could graph, it could be a circle and the orientation could be this way, or it could graph this way and you'd have an orientation that way. So when we graph them, we like to indicate the orientation as well.